Good evening to everyone. The last topic, classification of lathe machines. That means classification of automatic lathe machines. One classifications are semi-automatic and automatic. With the last two topics of classification of automatic lathe machines, we concluded the unit 2, which is lathe machine. Today in this class, we will discuss about unit 3, named as drilling and boring machines. Okay. In this topic, we will discuss about what is a drilling machine and principal working of drilling machines and operations performed on drilling machine. Next, different types of work holding devices and tool holding devices used in drilling machines and types of drilling machines. Coming to boring machine, what is a boring machine and why, in which places and why you are using boring machines or machining process, where we are using boring machines, what are the operations performed. Okay. Next, types of boring machines, twist drills. These are the topics we will discuss in unit 3, drilling and boring machines in part A. Coming to part B, we are discussing about shaping, slotting, planing machines. But today in this class we will discuss about part A, only about drilling and boring machines. Okay, I'm sharing my PPT. Okay, first of all, presentation on subject machine tools. Machine tools is a subject is for mechanical engineers, third years. In machine tool subject, we are discussing about unit 3 and continuing of unit 3, starting with drilling and boring machines. Next, unit 3. Is drilling and boring machine. First of all, what is drilling? Okay, I'm not talking about drilling machine. First of all, what is drilling? Drilling is nothing but producing a hole. That means producing a circular hole in workpiece by using of rotating cutter called drill. Okay, drilling is the one type of operation. Here we are producing a hole by using of rotating cutters. It is called nothing but drilling. The machine used for drilling operation is called drilling machine. Okay, observe the difference between drilling and drilling operation. Okay, drilling operation and drilling machine. Drilling is operation, drilling machine is used for drilling operation. That is the difference between drilling to the drilling machine. The drilling operation can also be accomplished in lathe. That means drilling operation can also be performed in lathe machine. Instead of tailstock, that means in the place of tailstock, we are fixing drill. Okay, in the place of tailstock, we are fixing the drill bit That means in tailstock we are fixing the drill bit and workpiece is fixed at chuck. That means it is in middle of spindle or chuck. The most common drill bits are used in twist drills. Okay, it is about drilling operation. Next, coming to drilling machine. Drilling machine common parts are spindle and work table. Spindle is nothing but turns the drill to advance into work. That means spindle is used for rotating the work. That means here it is rotating the drill bit. Next, work table. Work table used for holding the workpiece rigidly in place as a hole drilled. That means work table is used for fixing the workpiece. Other operations are tapping, reaming, boring, counter boring. Working principle of drilling machine. The main working principle of drilling machine is the rotating edge. Here, the working principle of drilling machine is nothing but the rotating edge of the drill. That means the end point of the cutting tool. End point of cutting tool. In this cutting tool is nothing but drill bit. The end point of cutting drill bit exert a large force. That means exert a high amount of force on the workpiece to produce a hole or to generate a hole. The main working principle is the end point of cutting tool. That means cutting tool bit or drill bit exert large amount of or high amount of force on workpiece to generate a hole. It is the working principle of drilling machine. Removal of metal in a drilling operation is used by shearing and extrusion processes. We already know about that. What is shearing and what is extrusion? Shearing is nothing but trimming or cutting. Extrusion means forward extrusion or backward extrusion. Here we are using forward extrusion. Shearing means cutting and extrusion means removing the metal process. Removing the metal or machining process. Specifications of drilling machine. Why we are telling about and why we are discussing about specifications of drilling machine. Okay, coming to anyone or coming to any mission. That means talking about any mission, we are preferring or we are starting with specifications. What is the height and what is the length? What is the breadth of any mission? Example, you can take any drilling mission, any milling mission. We are specifying the particular mission by using specifications of particular mission. Okay, we are specifying the particular mission by using of that machine specifications. Here, the drilling mission is specified by using of size of drilling table, largest bit machine can hold, maximum size of hole, and maximum size of the workpiece and power of the motor. These are the specifications of drilling machine. By using these specifications, we are specifying this drilling machine. It can generate hole up to this Okay, the maximum size is the maximum size of hole. It is the maximum size of workpiece. Here we are using size of drilling table. These are the main basic specifications of drilling machine. Next, tool nomenclature. In this, I am directing some directions here. One is shank, margin, body, flute, web, point. Point is the end point, cutting edge. First point or first part. I am specifying first part is the shank. Shank which is fixed inside the chuck. That means which is fixed at inside the spindle of drilling machine. Shank up to starting of margin, we are fixing shank into the inside of drill chuck. Next point is the cutting edge. Cutting edge is used for removing the metal or material of workpiece. Next, margin, body, fluid, those are the nomenclatures of tool. We are using single point tools or anything. Next, coming to types of drilling machines. In types of drilling machines, two classifications are there. One is based on construction, and coming to second one is based on feed. First of all, I am discussing about based on construction. And coming to based on construction, in these many classifications are there. First of all, I am discussing about one by one. Portable, sensitive or bench drilling machine, radial, upright drilling machine, gang drilling machine, multi-spindle drilling machine, automatic drilling machine, turret drilling machine, deep hole drilling machine. Coming to based on feed, that means second classification. Here also one classification is the hand and power driven portable drilling machine. First of all, we are discussing about based on construction portable drilling machine. Okay, here I am showing the figure of portable drilling machine. These type of drilling machines we are seeing, we can see anyway portable. Okay, the answer for this implies on a name as only. Portable means we can take this type of drilling machine to other works. Like, why we are preferring portable drilling machines for other works? Because of it having small lightweight. Okay, by using portable drilling machine we can generate holes up to now 12.5 mm diameter only. Okay, by using portable drilling machines we can generate hole up to 12.5 mm dia only. Why? Because of it is in small lightweight and small sizes. You can generate holes up to only 12.5 mm. This machine is driven by a small electric motor operating at high speed. That means here we are using small electric motors, stepper motors, but operating at high speeds. By using portable machines, we can generate holes any position. That means in an inclined position, in perpendicular position, parallel position, at any position we can generate hole by using of portable drilling machine. Portable drilling machines are very suitable for maintaining other works like electrical works, plumbing works, different types of works. We are preferring portable drilling machine. Because why? Because of it is in small lightweight and small construction is there in portable drilling machine. Coming to second one, sensitive or bench drilling machine. Sensitive or bench drilling machines are also similar to portable drilling machines, but it is not portable drilling machine. It is fixed to the bench. Okay. In name also I am mentioning bench drilling machine. It is not portable drilling machine. Okay. It is not portable drilling machine. It is fixed to the bench or mounted on bench drilling machine. So I am calling it as bench drilling machine. These are also light duty vehicles mounted on benches. By using sensitive or bench drilling machines, we can generate hole from 1.5 mm to 15 mm dia. By comparing sensitive or bench drilling machine with portable drilling machine, in portable drilling machine we can generate hole up to 12.5 mm dia. But coming to sensitive or bench drilling machine, we can generate or produce a hole from starting 1.5 mm to 15 mm dia. It is the difference between portable to bench drilling machine. Speeds are 800 rpm to 900 rpm are typical range. Next, coming to third one, upright drilling machine. Upright drilling machine is similar to sensitive drilling machine. Here also we can use power feed mechanism, and upright drilling machines are used for heavier works. But comparing of previous two machines, drilling machines, one is portable and the second one is the sensitive or bench drilling machine. Upright drilling machine is used for heavier works. In this, we can generate holes or drill holes up to 50 mm. Okay, observe this. In portable drilling machine, we can generate 12.5 mm dia holes. That means 12.5 mm holes. In sensitive, 1.5 mm to, observe this, 1.5 mm to 15 mm in sensitive. Coming to upright drilling machine, we can drill up to 50 mm, 50. Table can move vertically and radially. Okay, here I am showing the parts of upright drilling machine. Here, by using of handle, we can rotate. Okay, we can rotate the spindle. Drill bit is fixed inside the spindle. We are moving the handle only. For moving the spindle in reciprocating direction from upward to downward. It is the column, table clamp, table, horizontal arm, main drive, motor. Here we are giving the power supply to motor. We are giving the electrical power supply to motor, and then motor is connected to main drive. We are connecting main drive to the gearbox. That means main drive to the wheels, gear wheels, by using of belt mechanism. That means power feed mechanism. Belts are connected to contact main drive to the gear wheels. By moving or operating the handle, we can generate or produce by using of drill bits or Mr. drills. This is the upright drilling machine. Okay. Upright drilling machine. Next, radial drilling machine. Coming to radial drilling machine, it is the largest and most versatile drilling machine. Versatile is nothing but we can rotate the column in 360 degrees revolutions. It is the largest and most versatile used for drilling of medium to large workpieces. It can radially adjusted around the column in any direction or any position over the work. Okay, in this the most advantageous thing, that means in this most advantage thing is it is a versatile drilling machine. In this we can rotate or we can move or we can operate the column or work table in 360 degrees. That is the radial drilling machine. It is used for medium to large heavy workpieces. Types of radial drilling machines: plain, semi-universal and universal. Universal drilling machine is used for all works. Universal drilling machines are preferred for all industrial purposes. Okay. Gang drilling machine. Gang drilling machine. In gang drilling machine, drill spindles are mounted on single table or one table. In one table, we are fixing all drilling spindles on one table. Because of that reason, we are calling it as a gang drilling machine. In each type of the spindles can be independently set. That means here we are fixing the spindles at a different speeds and a different depth of cuts. Such these type of machines are useful when number of holes of different sizes are to be drilled on the same workpiece. Apart from drilling machine, by using of gang drilling machine, we can make the operations like reaming, counter boring, tapping operations by using of gang drilling machine. Turret type drilling machine. Coming to turret type drilling machine, the stations are set up with a variety of tools. In these, we can use numerical control also. Two fixtures are located side by side on the work table, thus permitted loading and unloading of one part, while the other part is machine. This reduces the machine cycle. That means what he is saying in turret type drilling machine. That means two fixtures are located side by side on the work table. In middle, I am showing the work table here by arrowhead work table. In this, we are fixing the fixtures side. Here, thus permits the loading and unloading of one part. And while unloading and loading on one part, then other part will be being machined. This reduces the machine time. That means it is by using of turret type drilling machine, we can reduce the idle time of machine. Deep hole drilling machines. These machines are used for drilling holes whose depth of cut is very long, or depth of cut is exceeds the normal drilling size. These machines are operated at high speeds and low feed. Okay, deep hole drilling. Why we are calling as deep hole drilling machines? Because of high depth. Okay, drilling holes are exceeds the depth of cut compared to normal drill size. These machines are either horizontal or vertical. Here I am showing horizontal deep hole drilling machine. Okay, these machines are usable for drilling deep holes in rifle travels and crankshafts. Very deep holes of length to diameter ratio 6 to even 30 required for rifle barrels, long spindles, oil holes in shafts, bearings, connecting rods. Okay, in these areas we are using deep hole drilling machines. Such drilling cannot be done in ordinary drilling machines and boring drills. Okay, drilling cannot be done by using of ordinary drilling machines and boring drills. In these cases, we are preferring deep hole drilling machines. Next, drilling operations. What are the operations performed on drilling machine? Those are drilling, reaming, boring, counter sinking, tapping, and spot facing. First of all, I'm showing drilling operations. First one is drilling. Operation of producing a hole by removing the metal from solid mass using a twist drill. Here I'm showing right side, I'm showing twist drill. The top tool is the twist drill. Producing a hole by using of twist drill. That is the drilling operation. Counter sinking is nothing but operation of producing tapered or cone shaped enlargement of end of hole. Here I am showing cone shape. Counter sinking is nothing but producing a cone shaped workpieces, cone shaped requirements by using of given tool. That one is known as counter sinking. Reaming. Reaming is nothing but operation of sizing and producing smooth round hole from previously drilled or bored hole. Reaming is a process Smoothing. Reaming is nothing but smoothing the process or smoothing the workpiece. Previously existence holes or previously existed bored holes. Next, coming to boring. Boring is nothing but enlarging a hole by means of single point cutting tool. We already know about that. The term of boring. Boring is a term regularly used for vehicles. Vehicle is going to be bore and enlarging the die of cylinder. In this case, we are using the term of boring. Next, tapping. Tapping is a operation of cutting internal threads. Okay, producing of internal threads in a hole by using of cutting tool. It is called tapping. Tapping is nothing but producing internal threads. Counter boring. In counter boring, we previously we saw about that what is countersinking, producing or generating a cone shaped workpieces, cone shaped holes. In this, what is counter boring? Enlarging top of previously drilled hole to given depth to provide square shoulder for head of bolt or cap screw. That means already previously drilled hole. By using this type of tool, by enlarging the area or enlarging a top of previously drilled position, that one is known as counter boring. Next, coming to tool holding devices. Here in this, I am not discussing about work holding devices in this syllabus. According to our syllabus, we are discussing about only tool holding devices. Those are used for only holding the tools, not on workpieces. Tool holding devices are used to hold or drive the cutting tool. The different methods used for holding drill in a drill spindle or by directly fitting the spindle to hole, by using drill sleeve, by using drill socket, by using drill chuck. First of all, I am discussing about tool holding devices. Drill press spindle provides by means of holding and driving cutting tool. Next, end may be tapered or threaded for mounting drill chuck. Most common are drill chucks and drill sieves are the main examples for tool holding devices. Next, drill fixed to the spindle. In this, I am showing that drill bit is fixed to the spindle. In middle section, I am showing the lock. That means it is not lock. It is a one type of lock. In this, we can fix the shank of twist drill to the spindle in the center of chuck slot. Drilling operations, drilling center hole, drilling deep holes, drilling thin material, drilling pilot hole. Drill chucks. Most common devices used for holding straight shanks or cutting tools. Those are containing three jaws that move simultaneously. Okay, we already know that about what is three jaw chuck and what is four jaw chuck. Three jaw is dependable, four jaw chuck is independent. Two common types are key with key and without key chucks. Most straight shanks drills mounted on drill press spindle tapered. Here I am showing the taper operation. Threads. Performing of internal thread is nothing but tapping. Next, types of drill checks. Key type, key without key, and precision key without key. Keyless means nothing but without key. Mostly commonly used key type drilling machines. Three jaws move simultaneously. Okay, this one is following three jaw check in lathe machines. Tighten with by using of key. In second one, we are not preferring key type. Okay, chuck loosened or tightened by using of hand without any key. Here I am using hand, not on using keys. keyless. Okay, in name also I'm saying about that keyless, without key. I'm using hand for loosening or tightening, giving that given tool. Precision keyless is nothing but hold a small drills accurately. Okay, here also I'm applying same procedure here for losing and tightening by using hand only. Drilling and drill bits. Types of drills: twist drill, step drill, core drill. First of all, twist drill. Twist drill is nothing but most commonly drilling machines used for producing a hole. Step drill produces a holes of two or more different diameters. Next, core drill used to make an existing hole bigger. That means twist drill is mostly commonly used drill bit for producing a holes. Step drill is used for two or more different diameters. Okay. For example, we are taking bench drilling machine is by using a bench drill machine we can generate or produce hole 1.5 mm to 15 mm dia. Thus, next it continue with upright drilling machine. It can generate or produce holes up to 50 mm, 50. It is the different or two types of diameters. Core drill is nothing but used to make an existing hole bigger. Already existed hole can be enlarged by using a core drill. Parameters definitions. First of all, I am discussing about what is the cutting speed. It is the main speed or peripheral speed of the drill. B equal to pi dn. We already know about that. What is pi and what is d and what is n. D is the dia of drill. N is the speed of rotation in RPMs. Feed rate. Feed rate is the movement of drill along the axis in RPM. Depth of cut D is capital D by 2. D is the dia of drill by 2. It is the depth of cut. Those are the main important relations in drilling machines. MRR, material removal rate, is nothing but volume of material removed by the drill per unit time. MRR is nothing but pi d square by 4 into F into N mm cube per minute. Material removal rate is pi d square by 4 into F. Machine time capital T. It depends upon the length of the hole to be drilled, to the speed N and feed of the drill bit F. Small t equal to capital T by L. Sorry, small t equal to L by F n minutes. Next, cutting speeds. Cutting speeds cutting speeds and feeds in drilling machine, as in the case of other machines, depends upon the many factors like what is the material to be cut and material of tool, type of finish and type of coolant used or capacity, and increasing the tool life. The formula for spindle speed or cutting speed in RPMs can be calculated by using RPM equal to cutting speed in meters per minute by pi into drill dia in meters. Cutting speed S equal to pi dn by 1000 RPMs. N is the spindle speed in RPM. Next, estimating machining time. In drilling operation, machining time is given by capital T equal to L by N into F. N is the RPM. Spindle speed in RPM. N is the RPM. F is the feed per revolution. N equal to RPM. F is the feed per revolution. Capital T equal to machining time in minute. What is meant by boring? Okay, these are the topics we will discuss about boring machine and types of boring machine. What are the operations performed on boring machines? Those are discussed later. Okay, bye all of you.